New simulations suggest that Planet 9, what we call Planet X or Nibiru, might not be a planet at all, but something much worse. This is a screenshot of one of the simulations of a star brushing past our solar system. So you can imagine if this type of a thing would be going on in our solar system, the havoc that it would wreak in our solar system. The star with whatever it carries with it. In our outer solar system, far from the light and warmth of the sun, things can get a little hinky. There, clusters of rocks have been orbiting in weird loops that some astronomers have attributed to the presence of a large unseen planet lurking on the solar edge's fringes. A couple of years back, NASA had a very nice looking lady announcing that there was a brown dwarf star at the edge of our solar system. And not many people pay attention to that though. But that's what NASA, a lady, announced to us a couple of years back. We have a brown dwarf star at the edge of our solar system. So far, searches for the hypothetical Planet 9, Planet X, Nibiru have yielded no such world. Of course, we have the Vera Rubin telescope going up in a couple of months, and perhaps they will find it with that. But there are many possible reasons for this. One strong contender of which is that there is no Planet 9, there never was. But if this is the case, then how do we explain the orbits? Well, a new paper has a potential solution. It could be an alien star. No, of course, it's not there now, but once upon a time, billions of years ago, a massive object could have passed closely enough to gravitationally stir up the orbits of objects in the outer solar system, causing the peculiar orbits. Some of those outer objects could have even ended up much closer to the sun, now seen as strange moons captured by the giant planets. That's the conclusion reached by a team of astrophysicists led by Susan Falsner of Forschungszentrum Jülich in Germany, who performed computer simulations to observe the effects stars of various masses and distances have on the outer solar system as they zoom by. The best match for today's outer solar system that we found with our simulations is a star that was slightly lighter than our sun, say about 0.8 solar masses, explains astrophysicist Amit Govid of Forschungszentrum Jülich. So 0.8, it's almost as big as our sun. That's not good. This star flew past our sun at a distance of about 16.5 billion kilometers. That's about 110 times the distance between Earth and the sun. A little less than 4 times the distance of the outer planet Neptune. Most of the stuff inside the solar system orbits in a more or less flat disk configuration. It's a relic of the way the solar system formed when the sun was a spinning baby star some 4.6 billion years ago. Material from the cloud around it swirled around it and fed its growth. Over time, this whirling material flattened into a disk, a lot like a ball of pizza dough flattens as it spins out. And what the sun did not devour then turned into the solar system with all the planets and asteroids and moons. And because nothing majorly disruptive happened to the solar system, that disk is where all of those planets and asteroids and moons stayed more or less. But the outer solar system is different. There are swarms of rocks that orbit the sun or pass the orbit of Neptune, the trans-Neptunian objects or TNOs, at remarkable incline angles. Some of these angles are so inclined that the object almost orbits the sun's poles instead of its equator. These orbits, some scientists point out, are consistent with the gravitational influence of planet up to 5 times the mass of Earth, but space is far from empty, and although there are no stars very close to the sun right now, once upon a time there were probably more. Stars are usually born in clouds where many other stars are born, and stars start their lives in pretty crowded environments. Falsner and her colleagues conducted more than 3,000 simulations, tweaking the different stars and how close by they pass the solar system, observing the results and comparing them to the known eccentric orbits of the TNO clusters. and they found that a star just a little smaller than the Sun, skimming past the outer solar system, could have produced the higgly-piggly shenanigans out there today. The flyby could even have produced the strange orbits of objects such as 2008 KV42 and 2011 KT19, which orbit in the opposite direction to our planets, at almost perpendicular inclinations. These objects, too, have previously been invoked in studies looking for evidence of Planet 9. And, according to the team simulations, up to 7.2% of the original TNO's population could have been flung inward towards the Sun. Some of these objects could have been captured by the giant planets as moons, says Simon Portegees-Zwart of Leiden University of the Netherlands. This would explain why the outer planets of our solar system have two different types of moons. The study is far from conclusive. There are quite a few reasons why we might not have spotted Planet 9, including the fact that it's very dim and very far away. And it's also possible that we're not operating with sufficient data. Everything that far from the Sun is hard to see. So the data we could have may be the result of selection bias, limited only to what we can see with our current technology. Nevertheless, the notion of a stellar flyby is not implausible, and it is rather a tidy solution. The beauty of this model lies in its simplicity, Fosner says. It answers several open questions about our solar system with just a single cause. The research has been published in 2 papers, appearing in Nature Astronomy and the Astrophysical Journal Letters, and it's on Science Alert by Michelle Starr. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.